We present semantic complete scene forecasting from a 4D dynamic point cloud sequence. We study a new problem of semantic complete scene forecasting in this work. Given a 4D dynamic point cloud sequence, the complete scene forecasting task is to predict the complete scene including occluded areas, and the semantic complete scene forecasting task predicts the complete scene along with semantic labels. As shown in the picture, combining observations from the past 3 frames, we can make a reasonable forecasting that the robot is about to walk behind a desk and is going to be occluded. Our key observation is that future forecasting and semantic scene completion are synergetic to each other and can lead to huge gains mutually if modeled properly. On one hand, future forecasting models the underlying scene dynamics and improves complete geometric understanding. On the other hand, a complete scene understanding allows future forecasting to focus on the object movements without bothering with sampling noise or occlusion variations. We make 3 main contributions: a new SCSF task, 2 large-scale embodied vision datasets IG-Play and IG-Nav, and a 4D backbone SCSFnet. We contribute 2 high-quality synthetic datasets with complete geometry and semantic annotations covering abundant indoor scenes and rich dynamics using the I-Gibson simulator. In IG-Play, the agent is moving and interacting with other objects such as toys and pops. In contrast, IG-Nav contains several robots navigating in the scene to provide other dynamics. For semantic complete scene forecasting, we design SCSFnet, an encoder-decoder structure which encodes the high-resolution point cloud sequence input, and sequentially decodes an implicit field with infinite resolution based on a dense voxel feature grid in a coarse scale. The network fills points into small voxels, and leverages Minkowski engine to encode the high-resolution sparse voxels using 4D convolutions. We fill the aggregated features of sparse voxels into 3D dense voxel grids with the same voxel resolution at each level, and leverage several 3D up convolution layers and skip connections to lift the resolution of the voxel grid to a higher level. 3 key components of SCSFnet are hybrid geometric representations, attention-based skip connections, and visibility grids. Our hybrid geometric representation combines the point cloud input, sparse voxel encoder, and dense voxel-based implicit field decoder. This hybrid representation can encode high-resolution input while at the same time forecasting a complete scene with infinite resolution. Attention-based skip connections feed sparse voxel features in the encoder to dense voxels in the decoder. Dilated convolution voxels from the encoder form the key and value. Up convolution voxels from the previous level of the decoder form the query. Finally, we concatenate the voxel features from multi-head cross-attention. Such design facilitates information propagation from partial to complete. Visibility grid is the visible empty space between the camera and the point. This information is critical since our main job while forecasting the scene change is to inpaint the occluded region but not the empty space. The task is much easier and can ease the need to model occlusion variations while solving the challenging SCSF task. Next, we show the results for SCSFnet and baselines in both our 2 synthetic indoor datasets IG-Play, IG-Nav and 1 real-world outdoor dataset Semantic Kitty. They are quite different and good performances on these datasets can demonstrate the generality of our SCSFnet. For SCSF task, we find that SCSFnet outperforms baselines on different datasets by large margins. We convert some strong baselines to our task. We find that 2-stage training in the baseline separates semantic completion from forecasting and reduces the ability of semantic extraction. Comparing the IOU of adjacent rows for the CSF task and SCSF task, we can infer that understanding object semantics is beneficial to scene completion. We also evaluate IOU when only considering movable objects or static objects. These improvementnets demonstrate SCSFnet can better handle dynamic objects, which is crucial to future forecasting. We aim to demonstrate the synergy between completion and forecasting. We evaluate SCSFnet in the traditional point cloud forecasting task to prove that understanding the complete scene benefits future forecasting. Then we evaluate SCSFnet in the semantic scene completion task to demonstrate the critical role of additional forecasting knowledge in completion. We establish the synergy between completion and forecasting by proving both directions successfully. We also conduct many ablation experiments to main components of our network. The results demonstrate the effectiveness of implicit representations, attention-based skip connections, visibility grids and voxel-based encoder. All of these key components contribute to our SCSF net.